All right, well, good morning, good afternoon, depending on what time it is. As you guys can tell, I'm not here. That cold is really kicking my butt. So I'm gonna do my best here real quick, go over a couple of homework problems from last night, and then introduce you guys to some of the basics with the inverse functions that we started talking about yesterday. You will be pleasantly surprised that it is extraordinarily straightforward and not very difficult to work with. That being said, your quiz is still tomorrow. Your quiz will be fully non-calculator. None. No calculators. Zippo. Zilch. You have to be able to do this stuff by hand. In the 7.3 stuff, we did 48 through 50 on the evens. And I'm just going to look at a couple of them real quick. Let's see here. Oops. I'm guessing that most of these things weren't that bad. Let's pick a couple real quick. Let's do 44 and 46 real quick. Let's see how we do. So, composite functions, f of x times g of x. For 44, it's 7x to the 2/5 times negative 2x cubed. Well, when you do this, numbers first, negative 14. And now it's, well, you have the same bases, different exponents. You're multiplying, so you add them. 2/5 and 3, well, 3 is the same thing as 15/5, so I went up with negative 14x to the 17/5. And then in 46, when you divide them out, I'm sorry, we divide them out, you have 9x to the negative 1 divided by x to the 4th. Well, this x to the negative 1 isn't happy, so it's 9x times x to the 4th, which would be 9x to the 5/4. Well, I'm sorry, I was coughing really bad. I had to stop for a second there. I need to sleep with the positive exponent. When you get into the 7.4 stuff, we did basically verifying that they were inverses. And you guys found out, I saw some of you guys in Flex, and you're like, oh, this really isn't all that bad. It's just a matter of substituting back and forth. Now, one of the reasons why they're saying x is greater than or equal to 0 here. If you look at this graph, it's a quadratic. It's a quadratic that goes like that. Well, it's a function because it passes what they call the vertical line test. Now, excuse me, when you're dealing with inverses, to check to see if an inverse of a function is going to be also a function, you have to check the inverse of vertical line, horizontal. So what they're saying here is the inverse of 1/3 x squared would not be a function because it doesn't pass what they call the horizontal line test. It passes in 2 spots. Because when you find the inverse, it would look like that. By saying the x value is greater than 1, you get that portion of the curve, which would pass the horizontal test. It's a little trick that they throw in here just to show that you can make these inverses work. It's not something that you have to be able to figure out on your own. What we're looking at being able to do is, can you verify the inverses work using your exponent rules? And then in a couple of minutes, I'm going to show you guys how to find actual inverses. So let's get back to this one. Remember to check if they're inverses. Is f of g of x equal to x? And is g of f of x also equal to x? So we write down the g equation. And I'm going to surround it with the x equation. Now, using my order of operational rules. There's nothing on the inside of the parentheses that I can do. Take care of my exponents. 2 times 1/2 is 1. So I have 1/3 times 3x, which gives me 3 over 3, which is 3 over 3x, which is x. We're halfway home. To check g of f of x, write down the f of x equation. Scroll this up. Then we're surrounded with the g of x equation. Now in this problem, this is times this right here. In this case, there is something I can do. 3 times 1/3 gives me 1x squared to the half, which gives me x. It works out their inverses. Finding inverses and verifying that they work is a very, very simple process. The other stuff that I want to look at, though, today with working with inverses is a little bit different. So let's look at that real quick. Excuse me. When we're looking at actual inverses, when we're trying to solve them out, then set them up, it is a very, very easy process to do. So let's take a look at it. All right, inverse functions. Now, this is some of the stuff just to kind of show you the idea of what actually is going on with an inverse. If you have a relation written out in table form or chart form here, you have your normal setup, your input and your output. What happens with your inverses is that they just switch places. Basically, in other words, x and y change spots. So when you work through these things in order to solve for an inverse, all you have to do is the following. You start with your original equation. To find the inverse of that, you exchange x and y, and then just solve for y. So 4. And divide by 2. So we have 1/2 x plus 2 is y. Those two guys are therefore inverses of one another. That's all it is to find an inverse. Again, excuse me, I want to find the inverse here. Y equals -2/3 x plus 6. When you write it out, sometimes it's easier to just put the negative in the numerator. It's a little bit easier to see. It's one giant fraction bar, right? Rewrite it. X equals -2/3 y plus 6. Subtract the 6. And then to undo multiplying by a fraction, you multiply by its reciprocal. So you have -3/2 x plus, let's see, the 18 over 2, 9, and therefore that's its inverse. You should be all happy right now because it's not very difficult. And I know you're waiting for the other shoe to drop. This is what we did yesterday. Still not a big deal. You guys did really well with this. What they're just using here is just saying that f and the inverse of f of x. That's all it is. It's not at the end of the world if we don't always use inverse with f to the -1. No big deal. We did this yesterday. Now, inverse of a power function. Like I said earlier, it doesn't change. What they're doing here is making sure that the inverse will be a function itself by saying that the only thing you're looking at is the positive x values. That's all it's saying. It's not the end of the world. It's a little, I don't even kind of, it's like a little misnomer. It's like a, to make sure it works, one of those types of things. So remember, another word for f of x is y equals. And then to do the inverse, just change x and y. Sorry, I had a coughing fit. And then again, to undo this, you have to take the square root. Well, remember, you took a square root over an equal sign, so it's going to be plus or minus square root of x equals y. That would be the inverse, but remember, here they're just looking for values of x to be greater than or equal to 0, which means all you need to worry about is the positive values. So just double check it, make sure you don't have plus minuses all the time. Okay? The rules don't change at all when you're dealing with power functions. You do the same thing. You flip-flop x and y and you solve. Let's do this. Since we're not going to have a calculator on our quiz, I'm not going to worry about doing graphing of this right now. I just want to work with this equation and find its inverse. So let's see, it is f of x, so y equals 1/2 x cubed minus 2. And we're going to find the inverse of that. Remember, flip-flop x and y and work backwards. Add 2, multiply both sides by 2. 2x plus 4 equals y cubed. Cube root it. Since this is an odd exponent, an odd nth root, I do not need to worry about a plus minus. And there's the inverse. So we get to the quiz stuff tomorrow. It's a matter of, can you find the inverse of a function? Can you verify that there is an inverse? Can you use your exponent rules to simplify? Things like that. Well, this one's actually even easier. So y equals 10x cubed. X equals 10y cubed. Divided by 10. Take the cube root. Excuse me. Now, when you're trying to find the inverses, sorry, coughing fit. At this point right here, you'll notice that you have the cube root of x divided by the cube root of 10. That means you have a root in your denominator. You can't have that. So you still have to rationalize. Sometimes it's easier for you guys to see it like this, x to the third over 10 to the third. To make this denominator 10 to the first power, we have to multiply top and bottom by 10 to the 2/3. Excuse me. So you get over 10. Here you've got the cube root of x. This, if you think about it, is the cube root of 10 squared. So that's the cube root of 100. Combine these together, and you get the cube root of 100x all over 10. That's your inverse. That's the trickiest part of some of these style problems, when you have to worry about fixing your denominator. Other than that, inverses are relatively easy. There's not a lot of craziness going on. And what I want you to do tonight is I want you to do the following. This is section 7.4. It's on page 427. I want you to do numbers 36 through 47. Do all of those. And we'll talk about, maybe we'll go over one of them for the quiz tomorrow. I don't think we're going to have any issues at all. You guys should do really well on this. Again, I'm sorry I wasn't around. I'm going to go back home and go back to bed. You guys have a great day, and we'll see you later.